So imagine that we have the question that simply says, solve x squared plus x equals 60. The word solve says that we might want to try using one of those methods that we've already looked at so far. The first method we looked at was this idea of using the function machine, the idea of doing and then undoing the steps that have been done. Now the problem with that in this case is that we wouldn't know which x to start with. We're going to have exactly the same problem as we had when we looked at the scales, and one of the x's would get very tangled up inside, not to mention that there is a squared, so this is automatically more difficult. Ideally, we're going to try and keep things to just x's or normal letters rather than having powers in there as well. We can't use the scales either from last week, because if we use the scales, we can only use the scales when there's x's on both sides of the equal sign, and we clearly only have them on one side here. There are two sets, but this is just a number. Now what this says, x squared plus x equals 60, this says that there is a number that we're using x as a code for, that when I square it and add another copy of that number to it, I get exactly 60. Exactly 60. However, a question like this would actually be worded slightly differently, and it would always be worded in exactly the same way. The question would say, solve using the method of trial and improvement x squared plus x equals 60 between 7 and 8 to 1 decimal place. Solve using the method of trial and improvement x squared plus x equals 60 between 7 and 8 to 1 decimal place. Obviously the equation will be different, the numbers either side will be different, but it will always be to 1 decimal place, and it will always specifically mention these words, trial and improvement. This question doesn't tend to turn up a lot, but when it does turn up it's worth a good few marks. We're talking sort of 5 or 6 marks, which admittedly, yes, is quite a lot, but if this turns up, it is a gift of a question, because every single question like this is exactly the same. You go through the same steps, different depending on the equation and the number obviously, but you go through the same steps every single time. And they will definitely be calculator questions. What we're going to do is we're going to draw a table. We're going to do this for any of these questions. We're going to have a column for x, we're going to have a column for the actual equation, in this case x squared plus x, and then we're going to have a judgment column. I will explain what that one is when we get to it. So what we're going to do, this idea of trial and improvement, is a bit like educated guessing, logical guessing. We have to do it in a very particular way. We don't want to just pick numbers at random, but we are going to test out different values of x and see how close we get to the 60. Hopefully we'll hit on one that is pretty close, if not actually 60. We're always going to start in the same way. We're always going to start with those two values mentioned in the question. We are told in the question that the solution is between 7 and 8. So we're going to test 7, we're going to test 8. We're going to do them in this way. We're going to test 7. Now what we're going to do is we're going to substitute that 7 into the equation. And then substituting it in, that will let us test out how close it is to the 60. Might be a little bit high, might be a little bit low, but at least we'll know roughly where we are. So the equation says that we need to take our x, we need to square it, and then we need to add a copy of that on. So we're going to do 7 squared, and we're going to add 7. 7 squared is 49, plus the 7 gives us 56, which is too low, because we're aiming for 60. But it's not too bad. It's not that far off. We're in the right kind of ballpark. You can use your calculators for these, and in fact I would encourage you to. You will need to by the time we get further on into this question. We're going to test out 8 next. So we're going to do the same thing. We're going to say, what if x was 8? What does the equation give us then if we test it out? So we're going to do 8 squared, and then we're going to add a copy of 8 to it. 8 squared plus 8. Well, 8 squared is 64, plus the 8 gives us 72, which you'll notice is too high. Now I would say that makes sense, because think about it, if 7 is too low and 8 is too high, there must be a number between 7 and 8 that hits on exactly 60. You might be able to use your judgment. Looking at that, 56 is much closer to 60 than 72 is, so you might already be thinking perhaps this number that's between 7 and 8 is much closer to the 7 than it is to the 8, and that would be a reasonable thing to do. But really, the only way we could possibly do it would be to test every single value. 7.1, 7.2, 7.3, 7.4, 7.5, 7.6, 7.7, 7.8, and 7.9. Why just those values? Because we're only looking for the answer to one decimal place. But we could halve our work. If we were to choose the next value very carefully, we would only have to test half of them. So the value that we are going to try next is 7.5. If we go exactly halfway between, then we either limit ourselves to the top half of the numbers, because it has to be, if 7.5 is too low, then we're looking between 7.5 and 8, or we're limiting ourselves to the bottom half of the numbers. If 7.5 is too high, then it must be between 7 and 7.5. So we're going to test the 7.5, and this is why you need your calculators, because we can now do 7.5 squared, add the 7.5. We're going to shove that in our calculators, and we're going to get 63.75. which is a little bit too high. Now that's okay, because that means if 7 is too low and 7.5 is too high, our answer, correct to one decimal place, must lie somewhere between the 7 and the 7.5. So I'm going to choose, to go nice and logical with this, I am going to choose, you could either go 7.4, 7.3, 7.2, 7.1, keep going until you find two that it's sandwiched in between, one that's too high, one that's too low. Or you could do it the way up, you could start at 7.1 and then go 7.2 and so on. I'm going to go down 7.4, I'm going to count down. I'm going to go 7.4 squared plus the 7.4, and I'm going to find out what that is. I'm going to put that in my calculator, and I'm going to hopefully come out with 62.16, which is still a little bit too high. I'm going to try 7.3 then, because maybe that one will be too low. Or maybe it will hit on exactly. 7.3 squared plus 7.3. Pop that in your calculator, 60.59. And we are so very almost there. But we need to hit exactly 60. So it must be just a little bit too high. So I'm going to go down again, 7.2. Maybe this is the big one. Maybe this is the one that will work. 7.2 squared plus 7.2 equals, pop that in your calculator, and we get 59.04, which is a little bit too low. And that seems to suggest that there is a problem, because we were aiming for exactly 60. But the thing is, the reason why we've not hit 60 is because probably it's a very, very long decimal. And that's why the instruction at the end of that question was very, very clear. Correct to one decimal place. As in, the answer is somewhere that's a little bit bigger than 7.2 and a little bit smaller than 7.3. It is somewhere in between those, but it is going to be closer to one of them. The answer is either going to be very close to 7.2, in which case that's our answer, or very close to 7.3, in which case that's our answer. Now we just need to find out which one it's closest to. So there is one final value that we can check, and that will tell us which one it's closest to. So we're going to check 7.25. We're going to go straight down the middle. We're going to look at those two, one that's too low and one that's too high, and we are going to go in between the two of them. 7.25. This is the final one we're going to check. Notice that this is the only one we've checked that is two decimal places. We are looking for correct to one decimal place. We have no need to ever check anything at two decimal places except for this final one to see which of the one decimal place answers that it could be, it is in fact closest to. So we're going to try this one final time. 7.25 squared plus 7.25 equals, we're going to put that in our calculators, and we're going to come out at being 59.8125, which is just a little bit too low. So 7.5 is too low, which means that our answer, clear that, our answer must be somewhere between 7.25 and 7. Our answer must be somewhere between 7.25 and 7.3. Think about it on a number line. There's 7.2, there's the 7.25, and there's 7.3. If 7.25 is too low and 7.3 is too high, our answer is somewhere in here, and anything in there will have to round, when you round it to one decimal place, to 7.3. So our final answer is x equals 7.3, correct to one decimal place. The only reason we'd ever do this method is if the question specifically asked us to using the method of trial and improvement. It will be very, very clear in the question. The wording of the question could be ever so slightly different, but it would have to mention the word trial and improvement, and it would very likely tell you which two numbers the answer is between, 7 and 8 in this case. And they would only ever go to one decimal place because they can test whether you know how to use the method of trial and improvement for one decimal place much more quickly than they can test whether you can do it for anything else. Okay, let's do another one. Let's word this one slightly differently, but still with the same basic elements in place. Using the method of trial and improvement, find a solution between 5 and 6, correct to one decimal place to the equation x cubed minus x equals 170. Very similar question, since we've still got this mention of trial and improvement, specific mention of the actual example that we're supposed to use. We've still got this between 5 and 6 idea, different numbers this time, but that makes sense, it's a different equation. We've still got this idea of the solution, the answer when we solve it, solution being just a different way of explaining that. Still with that solution being between two particular numbers, and we've still got this idea of correct to one decimal place. Notice that this time we've got an equation that gives us a much bigger answer. We've also got a cubed and we've got a subtract in there, but actually it shouldn't really matter. The fact that it's mentioned this trial and improvement specifically will be 5 or 6 marks worth of doing exactly the same thing as we did last time. We always set up the table in the same way. Our first column is our test values for x. Our middle column is the particular equation that we are looking at, in this case x cubed minus the x. So this says we're going to take our value that we're testing, we're going to cube it, so times it by itself, then times it by itself again, and then we are going to take off a copy of that value. And then we're going to make our judgment in the final column. So there's our basic table. First two values we're going to test. Well, we're going to test the two values that were given to us in the question. So we're going to test 5 and we're going to test 6. When we test the 5, we're going to put it into our calculator. We're going to substitute the 5 into that equation. So we can do 5 cubed, so 5 times 5 times 5, and then take away a 5. When we put that in our calculator, we should then get 120, which is of course too low. Which makes sense, because remember the answer is going to be between 5 and 6. So hopefully 6 will also turn out to be too high. We're aiming for that 170, remember, and 120 is clearly too low. So testing it with the 6, we do 6 cubed, and then we take away a 6. So 6 times 6 times 6, and then whatever we get from that, take away 6. That will give us 210, which is, pleasingly, too high. Now again, so there is some number between 5 and 6 that gives us as close as we can get to the 170. Now it could be that it's closer to 5, it could be that it's closer to 6. 170, actually, it's not, it's sort of around about the middle. It's 50 away from there and 40 away from there. So it's not really leaning particularly much closer to the 5 or to the 6. But, as with last time, we can save ourselves half a job and only leave some of the numbers in between 5 and 6 to test if we choose our next answer very carefully. So we are, exactly like last time, going to go straight down the middle and test the 5.5. We're going to substitute that into our equation. This is where the calculator particularly comes in handy. 5.5 cubed, and then take away a copy of 5.5. Doing that, we should get 160.875, which is too low. So now we can work systematically through 5.5 up to 6. So testing 5.6, 5.7, 5.8, 5.9, because eventually we'll get 2 where the answer clearly has to lie between one that's too low and one that's too high. So we're going to check the next one off. I'm going to go straight up to the 5.6. 5.6 cubed minus 5.6. It's probably better to do this fairly logically and go to the next one up or the next one down, rather than try a slapdash approach, jumping about in between. You're more likely to find the 2 that it's sandwiched in between quicker if you just test them in a sensible, logical order. And at most, you're going to have to test 4 things, which is not that big a deal, especially with the calculator. So testing it with the 5.6, we're going to get 170.016, which actually is not bad. We're aiming for the 170. So we are pretty much bang on the cusp of the 5.6. But it is technically slightly too high, because we were aiming for exactly 170. Now, if 5.5 is too low and if 5.6 is too high, that means there must be an answer between 5.5 and 5.6 that gives us exactly 170. Now, gut feeling and logic tells us it's probably going to be very close to the 5.6, but we need to test that out just in case. The fact that there is a cubed power and the fact that there is this subtract going on can change things pretty quickly. Cubed powers grow fairly quickly. So we can test out at the halfway point. And again, this is the only time we go to 2 decimal places, when we are at that final step of seeing which of our 1 decimal place potential values our answer, the solution that we're looking for, is going to be closer to. So we test the 5.55, exactly halfway between 5.5 and 5.6. When we test that, we cube it and then take off a copy of it, and that will give us 165.403.875, which is too low. So then our answer must be sandwiched between these last 2. So if I clear the top of this table, we can just make our final conclusions. Our answer then must be sandwiched somewhere between 5.55 and 5.6. If we then think about those on a number line, with 5.5 at the bottom, 5.6 at the top, and there's the halfway point, 5.55. If 5.55 is too low and 5.6 is too high, then our answer is somewhere in this section here. Any number in there, including the 5.55, when we round it to 1 decimal place, we'll have to round up to the 5.6 because it's more than that 5 halfway point. So our answer then, x equals 5.6, correct to 1 decimal place.